Testing, 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 testing. Hey guys, Travis Gillespie here. Today we're graphing functions. In this first example, it asks us to use the given x values to write solutions of the equation as ordered pairs. So below we see y is equal to 6x plus 2, and we're given x is equal to 1, 2, 3, or 4. And we're given that x can equal 1, 2, 3, and 4. So let's go ahead and write or highlight information from this. So from here, let's go ahead and highlight key information. So use the given x values to write a solution of the equation as ordered pairs. So I'm going to highlight ordered pairs. And I'm highlighting this information. Ordered pairs, they're keywords because we can use ordered pairs, or we can generate points to graph. And once those points are plotted and we look at the graph, we can use that information to understand functions fairly quickly. So we're going to generate these ordered pairs by using the given x values below. The first thing I want to do is set up a table. So let's go ahead. Now I'm intentionally making this table wiggly and not perfect, because our goal right now I want to have a little bit of fun with this table, so I'm just going to kind of use this squiggly line. And over here I'm going to say, hey, these are my x values. So let's change pen colors. I'm going to use red for my x values. And after that, I'm going to write that equation that was written down. But I'm just going to leave that y and equals portion out of it. I'm just going to write 6x. Now next, what I'm going to do is write down 6x plus 2 in this next section. So let's change pen colors. 6x plus 2. So I have my x values, my equation, and I'm going to put my y values down. And then at the very end, what we can do is write our ordered pairs out. So we have our x value followed by that y value. So let's start with our x values. I'm just going to write them out in a list, and I'm going to highlight the x values. We were given 1, 2, 3, and 4, so I'm going to write those in the list. I'm going to add an extra value in. It's okay to generate your own ordered pairs if you would like. I'm going to stick with the numbers that were given to me because they might be important to the problem. However, I want to see what would happen to my ordered pairs if I used However, I want to see what will happen to the ordered pair if I use the value 0. In fact, I could have even used negative numbers if I wanted to. -1, -2, -3, and so on. I'm just going to add 0 in. So we have 0, followed by 1, followed by 2, 3, and 4. The next thing I'm going to do is just switch to my blue pen and rewrite this below as 6 times, not x, but what's our value for x in this first ordered pair? Well, that value is 0. So 6 times 0 in this case, plus 2. Well, 6 times 0 is equivalent to 0. And if I add 2 to 0, well, I'll get the value 2. So my first ordered pair is 0 followed by 2. And let's go ahead and write that in. I'm going to save this writing the ordered pairs out at the very end. That way, once you get the gist of the content, the information I'm giving you, the content or the information I'm giving to you, you won't have to watch me. The content or the information I'm giving to you, you won't have to watch me write out the entire list of ordered pairs. You could skip forward. You can end the video if you want to, or so once you get the gist or the content, the information I'm giving you, you can start practicing these on your own. Stop the video if you want. You won't have to watch me write out the entire list. So the next problem we're working with, we have 6 times 1. Oops. So this next equation, so the next one we're working with here, it's 6 times 1. Plus 2, and in fact I'm just going to start writing these out. 6 times 2 plus 2, six times 3 plus 2, six times 3 plus 2, and finally 6 times 4 plus 2. Okay, so 6 times 1. 6 times 1 gives me a value of 6, and then I can add 2 to 6, which will give me a value of 8. 6 times 2 is 12, plus 2 is 14. 6 times 3 is 18, plus 2 is 20. And 6 times 4 is 24, plus 2 is 26. Now, one thing I want to note, when you're writing your ordered pairs out, your x value always comes first. Your y value always comes second. And what you'll start to see is, when you use different values for x, you can find out what the out. Now one thing I want to note when you're writing your ordered pairs. Now one thing I want to note about when writing your ordered pairs out is that your x value always comes first, y always comes second. But you can create your own x values to find out what those outputs will be, the y values will be. Cool. So when x is 1, y is 2, y is 8. When x is 2, y is 14. When x is 3, found that y is 20. And when x is 4, y is 26. Cool stuff, guys. So we can use functions to create ordered pairs. And once this information's graphed, use the information that's graphed to better understand the function you're dealing with. Cool stuff. I'll see you in another video. Hey guys, Travis, testing. Hey guys, Travis Gillespie here. We've been working with functions and now we're dealing with testing. Hey guys, Travis Gillespie here. We've been working with functions and now we're dealing with graphing functions. So in this example, we're asked to determine whether the ordered pair is a solution to the given equation. We're given the ordered pair 4 and 32. Hey guys, Travis Gillespie here. We've been dealing with functions, and in this section we're graphing functions, and in this example it asks us to determine whether the ordered pair is a solution to the given equation. So our ordered pair, we're given 4 as our x value and 32 as our y value. And the function y equals 8x, or 8 times x. Testing. So if you're ever given an ordered pair, what you can do is use it to see if it satisfies the function, and that's what we're going to do. If it satisfies the function, then it's going to be a solution to that equation. So in order to find out if the ordered pair is a solution to this equation, what I need to do is substitute my x value in for x and my y value in for y. So remember, x comes first, y comes second in an ordered pair. So for my y value in this equation, I'm going to substitute 32 in. So 32 is equivalent to 8 times my x value, which is 4. 8 times 4. So if I plug 4 in for x and 32 in for y, do I have an identity here? What I'm asking myself, does 32 equal this information? Are they identical to one another? Well, 4 times 8, 8 times 4 is 32. So let's rewrite this as 32 is equivalent to 8 again times 4 is 32. This checks out. We have an identity. Therefore, yes, the ordered pair 4 and 32 is a solution to this function. Cool stuff. I'll see you in another video. Hey guys, Travis Gillespie here. We've been working with functions and graphing functions. This example asks us to use the graph of the linear function to find the value of y. This example says use the graph of the linear function. This example says use the graph of the linear function to find the value of y for the given value of x. And we're told here that x equals 4, so we're given x equals 4. Graphs are one of the most powerful tools you can use when dealing with functions, because you can visualize that function. You can interpret it, analyze it, so let's go on up and highlight that key information above. Use the graph of the linear function to find the value for. Find the value of y, so that's what I'm going to highlight here. Find the value of y. for the given value of x. So below we have this graph, and one way we can visualize functions is by making a graph. And we can extract a lot of information when looking at graphs. Now if you notice here, this graph has a straight line. Now if you notice here, this graph, it's a straight line. And whenever you have a graph that's a straight line, well, the equation for that graph, or the equation for that line, is called a linear equation. So whenever you have a graph that's a straight line, the equation for that line, or the equation for this line, and this. So whenever you have a graph that's a straight line, the equation for that line, it's called a linear equation. But let's go ahead and find out that y value when x is equal to 4. So we always start at the origin, and the origin is located on your coordinate plane at 0, 0. I'm going to highlight that coordinate right there, 0, 0. That's our origin. And I know that x is equal to 4. So whenever working with the coordinate plane or working on the coordinate plane, we always move left and right first. That's our first goal. We want to, if we treat it like being in an elevator, we've got to step into the elevator, move horizontally before that elevator can move up or down. So on the coordinate plane, we're going to move horizontally first before we move up or down. So starting at the origin, I'm going to move 4 units. I'm going to move to the right because my value is positive. It's positive 4. If I'm moving on a number line, or if I'm moving horizontally on a number line, that's left or right, numbers that are positive are to the right of 0. So I'm going to move 1, 2, 3, 4 units to the right. And I'll stop right here at 4. And now I want to look up and find out where that line is. And that line's... And now I want to look up above this 4 and find out where the line lands. So now I want to look up above this 4 and find out where that line is moving above this 4. Well, it's moving up here, so let's find out how many units I have to move up from the x-axis to pinpoint and locate that line. To pinpoint and locate the line, we'll have to move up 1 and 2 units. So the line is located here. So again, we already know our x value. When we write ordered pairs, x always comes first, followed by y. So my x value, it's already been given to me, it's 4, followed by the y value. Well, let's find out what that is. That's positive 1, positive 2. That elevator had to go up 2 units. so the y value is 2. So when x is 4, y is 2. So again, our overall goal here was to locate or know where the function. So again, our overall goal here was to locate where the function was at this point. The function's here at 4, 2. You can ask where's the function at its height when x equals 4. Its height is 2. The y value is 2. Another way you could have written this, it was when x equals 4, y equals 2. Rather than writing it this way below, you'll most likely write it as an ordered pair, 4, 2. Cool guys, I'll see you in another video. Hey guys, Travis Gillespie testing. Hey guys, Travis Gillespie here. We've been working with functions and graphing functions. This example asks. Hey guys, Travis Gillespie here. We've been working with functions and graphing functions. This example wants us to graph the function described by the equation below. So we're going to use this equation to graph our function. But how can you build this graphical visualization? But how can you graphically build this visualization? But how can you graphically build a visualization of this function? Remember, a powerful tool is to create a graph. Remember, a powerful tool for understanding or interpreting functions is to build a graph. It will allow us to see an overall picture of what's happening. It will allow us to see an overall picture or structure of what's happening with that function. So the first thing I want to do is create a table. So the first thing, let's create that table. My x values are going to come first. Followed by my equation. Negative x minus 2. Followed by my y value. And then in previous videos you saw me in previous videos or other courses, you may have had teachers that have you write the ordered pair afterwards. I'm limited on space, so I'm not going to write the ordered pair. But I would suggest creating an extra column here to where you have the ordered pair at the end. And I'm actually going to fix this. I'm going to erase that information. What I want to do is make sure that I have that ordered pair at the end. It's not necessary to have. And I'm going to make sure I create just enough space so that we have an ordered pair at the end. Now it's not necessary to have. Not all your teachers are going to make you create a column for your ordered pair. But I just think it's safe to have, and it's a good habit to get into just for now until you get really comfortable with them. Now when generating ordered pairs, you get to create whatever x values you want. I like to keep the math simple, but I like to get an overall view of what my graph looks like, or what my function looks like. So I'm going to start with negative 3. Negative 3, negative 2, negative 1. I'll use the value 0, positive 1, positive 2, and positive 3. Now I'm going to substitute all of my x values in for this x. I've got to pay special attention and be really careful with that negative sign that's already to the left of x. If I have a negative sign already to the left of x and I'm going to substitute a negative value in, I've got to make sure that that negative sign that's already up in the equation stays in place. Now I can use parentheses to plug this negative sign, negative 3 in the parentheses. So negative 3 minus 2. And right now I'm just going to fill out the entire column before we move forward. So now I have my negative sign. So now I have my negative sign. Negative 2 in the parentheses, substituting that x, minus 2. Negative, negative 1, minus 2, negative 0, minus 2, negative, positive 1, minus 2, negative positive 2, minus 2, and negative positive 3 minus 2. And let's go ahead and fix that 3 real quick. Now let's go ahead and I'm going to work this first problem out below. I'm going to use a different colored pen. So we have negative times, or negative. So I have negative, and then in parentheses, negative 3, followed by minus 2, or subtracting 2 after that. Now what's going to happen with this negative sign outside of the parentheses and this negative sign inside of the parentheses? Now there's a couple of ways I can think about this. One way I can think about this is I have two negative symbols next to each other. So I could just slash and dash, which means just turn or rotate this negative sign on the outside of the parentheses vertically and lay it on top of that negative sign inside the parentheses. That's slash and dash, which means, hey, let's take this negative sign inside the parentheses, and if I were to remove the parentheses, then let's just slash and dash. I'm going to turn this negative sign inside the parentheses vertically and lay it on top of the one outside of the parentheses. Well, that just creates a positive sign. So I could have positive 3 take away 2. Well, let's just use this number line for a second over here. I don't even have to draw one up. This would be 0. And if I moved out to positive 3, 1, 2, 3, 1, 2, 3. So here's positive 3. And negative 1, negative 2. Take away 2. So here's negative 2. Well, one way of thinking about this is asking myself, which value is further away from 0? Is it positive 3 or negative 2? Well, it's positive 3. So is my number going to be more positive or is it going to be more negative? It's going to be more positive. That's one way of thinking about this problem. And then you ask yourselves, what's the difference between 3 and 2? Well, the difference is 1. But is it going to be negative 1 or positive 1? Since 3 is further away from 0, and we already said our answer is going to be more positive, 1 has to be a positive value. But there's another way of doing this work. So this time, instead of drawing negative 2 on the number line there, let's just move out to positive 3 along this number line. So we've moved 1, 2, 3 out to positive 3. So from 0 to positive 3. Then we stopped. Now I've got to move back in the other direction. So from 0 to positive 3, we've moved out in this direction. Now I've got to U-turn and move in the opposite direction, back 2. So negative 1, negative 2, or take away 2. And I land at positive 1 as my stopping point. Therefore, when x is negative 3, y has to be positive 1. I'm going to use a red marker here, positive 1. And let's erase the information on the graph. I'm going to work through the other problems a little bit quicker. Now I'm going to erase this information below, and let's get rid of that arrow as well. Now there's another way of thinking about this problem, but I have to ask myself, I'm going to rewrite this as well. Negative x minus 2. I'm going to ask myself, what value could I place to the left of x to multiply by x to get the same value, or to get its identity? Well, that value would be 1. When you multiply a value by 1, you get its identity. You get the same value. Well, in previous videos, we've discussed the identity property of multiplication. It states, you know what, if you multiply a number by 1, you get the identity of that number. So if I multiply 1 times 1, I get 1. If I multiply 1 times 2, I get 2. If I multiply 1 times 3, I get 3. The same holds true if I multiply 1 times x. 1 times x is x, but I don't have a positive x here. I have a negative x. So what can I multiply negative x by to get negative x? Well, I could still multiply it by 1. There could be a 1 hiding between this negative sign and the x. And if I were to multiply negative 1 times x, I would still get negative x. The same would hold true up above. I'm going to change pen colors. I could reveal the 1 that's been removed, that's in between this negative sign to the left and the negative 3 inside the parentheses. When I multiply negative 1 times negative 3, well, I have two integers that have the same signs being multiplied. Therefore, the value is going to be positive. Negative 1 times negative 3 is positive 3. That will give you the same result as if you did the slash and dash method when you just rotated that negative sign inside the parentheses and laid it on top of this negative sign outside of the parentheses. So either way, it's going to take some practice. Whatever you like better, you can use it. I'm going to erase the information below and work through these next problems a little bit quicker. So negative 2. Well, that's going to, I have two negative signs, so that's going to give me a positive. So I have positive 2 minus 2. Well, 2 minus 2 will give me a value of 0. So when x is negative 2, y is equal to 0. Alright, here we have negative 1, which becomes positive 1. Positive 1, take away 2, will give me a value of negative 1. One thing I would suggest before I move forward here is you give yourself a little extra room when working out problems like this so that you can write below these problems. So give yourself space so you can show your work and work through these problems so you get the correct values for y. So now I have a 0 in the parentheses. It's neither negative nor positive. It's neutral. So regardless if there's a negative sign out here or not, it's still going to be 0 in the long run. Think about it. If I had negative 1 outside the parentheses and multiplied it by 0, my value would still be 0. So we have 0, take away 2. So the answer is going to be negative 2 in this case. Are you starting to see a pattern here? Yeah, it looks like my y value is decreasing by 1 unit each time. Okay, so this next one might be negative 3, but let's just work through the problem just in case. So now I have positive numbers that are going inside of the parentheses. So what's going to happen here? Well, since I have a positive number inside the parentheses and a negative sign outside to the left, it looks like my number's just going to switch to being negative. So this is negative 1, take away 2. Well, I could use the number line to work through this problem, or I could create a visual if I wanted to. I could create negative integer chips. So I have negative 1, and then I'm going to take away 2 more. So I'd put 2 more negative integer chips on the screen. So there are 3 negative integer chips total. Let's go ahead and erase this information. My value should be negative 3 since I have 3 negative integer chips below. Hey guys, I just had a little bit of technical difficulty. I'm trying to get the screen back on here. I hope that's not too much of a shift, but oh well, we'll work through this. So the last problem we found out, I had 3 negative integer chips on the screen. Therefore the y value was negative 3. Let's move to the next one. I have negative 2, take away 2 more. That'll give me a value of negative 4. And negative 3, take away 2, will give me a value of negative 5. So let's go ahead and write these ordered pairs out over to the side. I'm going to use a totally different pen color this time. So my x value starting out was negative 3, my y value is positive 1. When my x value is negative 2, y is 0. When x is negative 1, y is negative 1. When x is 0, y is negative 2. When x is 1, y is negative 3. When x is 2, y is negative 4. And when x is 3, y is negative 5. So take a look at this information real quick. Take a look at what's happening between x and y. So as your input, or the x values, increase, your outputs are decreasing. Your y values are decreasing. Let's go ahead and use these ordered pairs to graph the function on this coordinate plane. So the first ordered pair is -3, +1. We always start at the origin. So I'm going to move in the x direction first, left or right, then the y direction second, up or down second. Get into the elevator before you move up or down on that elevator. So starting at the origin, I'm going to move -1, -2, -3 units to the left, followed by 1 unit up. My y value is 1 unit up. Now take note real quick that I haven't numbered this coordinate plane. And that's okay, as long it actually depends on your teacher. So find out what your teacher wants. But as long as each unit is only increasing or decreasing, but as long as I move along this coordinate plane, but as long as each unit or each move along the coordinate plane is only 1 unit or changes by a scale of 1 unit, I shouldn't have to number the order. I shouldn't have to number the coordinate plane. I shouldn't have to number the coordinate plane. Who's ever looking at the coordinate plane should be able to understand that each space is 1 unit, or each move is 1 unit. The only time you should really number the coordinate plane is if you're changing by more or less than 1 unit between each space. Okay, so we've graphed the first ordered pair. Let's go ahead and plot the second point. -2, 0. So going back to the origin, start at the origin. You're going to move 2 units to the left in the x direction. 1, 2, and then your y value is 0. So it's actually going to land right here on the x-axis. Okay, so the next ordered pair is -1, -1. So now starting at the origin, I'm going to move -1 to the left, then down 1 unit. Okay, before I move forward to the next ordered pair, just know you only need 2 points to plot a straight line. However, I want this graph to be really accurate, so I'm going to get as many points on this coordinate plane as I can. So the next ordered pair is -1, -1. Let's go ahead and plot that. Start at the origin, move -1 to the left, followed by -1 in the y direction. The next ordered pair is 0, -2. So starting at the origin, my x value is 0. I'll move 0 units to the left or right, followed by a change in -2 in the y direction. So I'll move down 2 units in the y direction. All right, the next ordered pair is 1, -3. So this time my x value is positive. I'll move 1 unit to the right. My y value is -3, so I'll move 3 units down, 1, 2, and 3. So my next ordered pair is 2, -4. Starting at the origin, I'm going to move 2 units to the right, then 4 units down, 1, 2, 3, and 4. And finally, my next value or ordered pair is 3, -5. Starting at the origin, I'll move out 3, 1, 2, and 3, then move down 5, -1, -2, -3, -4, and -5. Now I feel comfortable. I feel like I have enough points plotted on this graph. If you wanted more, you could definitely do so. You just have to add more x values to generate additional y values. But the last thing I want to do is draw a straight line through these points. So the goal is to draw as straight of a line passing through all of these points as possible. And you want arrows on both sides of your line. And now you can see how powerful graphing a function is. Whereas this table over here, it's good to have. However, it has its limits. You only have a few ordered pairs or a few points to look at. Whereas the graph, on the other hand, allows you to see all the points in between and all the points beyond what you've plotted on the coordinate plane. So a graph allows you to see all of the points. Remember, when graphing, you always move in the x direction first, y direction second. And if you plot correctly, you can watch the pattern continue on. Also, it's probably good to note that to play it safe, you probably want at least 3 numbers. I typically use at least 1 negative number, 0, and 1 positive number. That's to play it safe. However, the more points you can generate, the more accurate your graph can be. When you draw a line, it allows you to extrapolate more information. Regardless if you use a table or a coordinate plane, a graph, functions allow you to see the corresponding y values associated with those x values. Functions allow you to see the corresponding y values that are associated with an x value. Cool stuff, guys. I'll see you in another video.